Calculus, video 22, hyperbolic functions. Alright, so today we're talking about hyperbolic functions. We are not going to get into the full details of hyperbolic functions. That will come more in Calc 2. But just as an introduction into hyperbolic functions, thinking of hyperbolic functions as an extension of e to the x. So what's going to happen is we're going to define these functions. We call them hyperbolic functions, and sometimes that scares people because it's for some reason a scary name. But they're really not. They are just the sum or difference of versions of e to the x. So for example, the first hyperbolic function we're going to look at is what's called hyperbolic cosine of x. This is called hyperbolic cosine of x. Right, that is its name, hyperbolic cosine of x. And it's an interesting name because it's not a trig function. Right? Cosine of x is a trig function, sine of x is a trig function, tangent of x is a trig function. It has to do with the waves, right? All those are trig functions. We define those functions as the ratios of, like, say, opposite to the hypotenuse on a right triangle. Right? That's how we define trig functions. Hyperbolic cosine is not a trig function. The reason you will see cosine, hyperbolic cosine, is because it behaves like a trig function sometimes. Right? Because it has some of the same behaviors as our trig functions. We kind of recognize the connection between them, and therefore when we named it hyperbolic cosine, but it's not itself a trig function. Okay, so hyperbolic cosine of x, or for short, we sometimes call it cosh, a long O, cosh of x, right? So cosh x, or hyperbolic cosine of x. And the definition for hyperbolic cosine of x, or cosh x, is again just a combination of e to the x, that exponential function we were talking about. It is e to the x plus e to the negative x divided by 2. Alright, so whenever we get to hyperbolic functions, don't be scared of them. They are nothing more than a combination of e to the x's, right? Some version of e to the x, in this case e to the x plus e to the negative x divided by 2. And when you think about that, what are you doing when you add two things and divide by 2? You're finding the average of those two things, right? If I give you 10 and 16 and I say find the average, you could take 10 plus 16, 26 divided by 2 is 13. It's the average of the two things. The hyperbolic cosine is nothing more than the average of the exponential function e to the x and the exponential function e to the negative x. We sometimes call that exponential decay. Right? The hyperbolic cosine is simply the average of these two functions. If you were to go halfway between both of those functions, put a dot, and then connect all the dots, you get the hyperbolic cosine. Where they intersect there on the y-axis is at 1. And if I just were to put dots, what I would consider to be kind of halfway between these two functions, you get something that looks kind of like this. And before you say, oh, it's a parabola, well, it's not a parabola. It's wider than a parabola, right? It's wider than a parabola. This is the graph here in blue here of y equals hyperbolic cosine of x. A little bit more about that. If we were to take that function, the hyperbolic cosine of x, we could create what is called a catenary. And a catenary is something that happens in nature. It's defined by y equals some constant times our hyperbolic cosine of x over that same constant a. And it looks like this. You can think about like poles, right? Electrical poles with the electrical wire hanging down, phone wire, that kind of thing. If you have a pole and another pole, and you have an electrical wire, or any wire, any sort of rope or wire that is longer than the distance between the two poles, and you attached one end of the rope or wire to this pole and one end of the rope or wire to this pole, The rope, because of gravity and structure, it would hang down. Guess what that shape is? That shape is a catenary, based on your hyperbolic cosine. Okay. And if you took that catenary and you flipped it upside down, an upside down catenary, an upside down catenary, you get this. And that shape is a stable structure. And because it's a stable structure, that means it's going to be used, or has been used a lot in things like bridges, arches. Right, different buildings that involve some sort of a curved portion. Bridges, arches, buildings of that sort. In fact, the Gateway Arch, right, the Gateway Arch in St. Louis, has a formula that uses a version of this hyperbolic cosine. It's a little bit more complicated than just your basic catenary. Uses a version of the hyperbolic cosine function. In fact, if you go to the Gateway Arch and you go inside in the bottom big area, you will see a plaque that talks about how they created it and actually has that function there. And you could probably Google it as well. One more. Let's do one more. So that's hyperbolic cosine. Hyperbolic sine is very similar. Again, not a trig function. Hyperbolic sine of x. Also referred to as sinh of x. Sinh. Sounds like what? Cinch, maybe? The sinh of x, or the hyperbolic sine of x, is defined as very similar to the hyperbolic cosine. It's e to the x, and you can think of this as two ways. I like to think of it as plus the negative e to the negative x over 2. In other words, it's the average of e to the x and negative e to the negative x. Looks something like this. If e to the x looks like that, and e to the negative x is like the exponential decay, but then the negative in front of that flips that upside down, right? Now you have a function that looks kind of like this, where exponential decay, but it's upside down. Close. Not the best graph there. Okay, we'll go with that. And the hyperbolic sine is simply the average of the two. In other words, if you go halfway in between those two graphs, you get hyperbolic sine, which you might say looks like an x cubed graph. It's not exactly. It's wider than an x cubed graph. Kind of reminds you of a tangent, but tangent, remember, has vertical asymptotes. So more of a widened out x cubed graph. That there in blue is called the hyperbolic sine of x, or sinh x function.